binary number system, the basis of all things Boolean and logical. We're going to have a look at how it works and how to convert numbers between our normal everyday base 10 or decimal system and binary and back again. Before we do that, I just need to draw your attention to this little box here and just understand something. Take my word for it if the maths boggles your mind, but x to the power of 0, x being any number, equals 1. So it doesn't matter what that number is. It can be 200, 2000 or 2. If you raise it to the power of 0, the outcome is going to be 1. Any number to the power of 1 equals that number. So 7 to the power of 1 equals 7. 2000 to the power of 1 equals 2000. That's pretty important when you're looking at the weight of each individual numeral in a number. And so yeah, we're just going to have a look at the base 10 system that we use every day, and just as a quick refresher, because I think it's important to, or there is benefit in looking at it side by side when you are looking at binary and how binary works. So we'll pick a random number, 2135. Okay, so looking along our scale here, basically each slot in a number, or each position, represents a value of 10. So our first one is 5 times 10 to the power of 0. Then we have 3 times 10 to the power of 1. Then we have 1 times 10 to the power of 2. And 2 times 10, it's the fourth position, 2 times 10 to the power of 3. Okay, so as I said to you before, any number raised to the power of 0 equals 1, so 5 times 1 is 5. Again, any number raised to the power of 1 equals that number, so 10 raised to the power of 1 is 10, 3 times 10 is 30. 10 times 10 is 100, 1 times 100 is 100, and 10 raised to the power of 3 is 1 with 3 zeros, which is 1,000, 2 times 1,000 is 2,000. And we add it all up and we get 2,135. Blown you away? Okay, so now we're going to look at how that works with binary. So we're just going to invent a nibble now, which is a 4-bit binary value. And so we can see that basically we have either zeros or ones in the binary system, which is base 2. There are 2 numerals that we have at our disposal to create numbers. So we're looking at our least significant bit, which is a 1, which is 1 times 2 to the power of 0. Our second least significant bit is 1 times 2 to the power of 1. We have nothing in the third slot, so we can just leave it as 0. And in the fourth slot we have 1 times 2 to the power of 3. Okay, so as we should now all be aware of, any number raised to the power of 0 is 1, so 1 times 1 is 1. Any number raised to the power of 1 is that number, so 2 to the power of 1 is 2. 1 times 2 equals 2. We don't have to worry about that third bit there. And the fourth bit is 1 times 2 to the power of 3, which is 2 times 2 times 2, which is 8. So we have 8 here. And so we add those numbers together and we come up with 11. Okay. So if you actually look at what's occurring on this, I guess, if you want to call it scale, all that happens is the numbers double as you add a position, or it becomes the next weighted number. So you start with 1, 2, 4, 8, 16, 32, 64, 128, 256, working across. Okay, so now we're going to look at converting a decimal number into binary. So we'll use the number 1130. Now the way that, there are a few different ways you can do this. This is the way that I learned, and I'm quite a fan. It works for me. It can be a little bit long-winded. If you have a phone, or you have a calculator on your computer, so you can do it pretty quickly, but there is some value in understanding what's actually going on, I think. So the way that I do it is, we have our number, we divide it by 2. 1130 divided by 2 is 565. Is there a remainder? No, there isn't. So just put a 0 in our little side box there. Then we divide it by 2 again. 565 divided by 2 is 282, with 1 left over, because it's an odd number. So 282 divided by 2 is 141, and there's no remainder there. 141 divided by 2 is 70. There's a leftover there. 70 divided by 2 is 35. No remainder. 35 divided by 2 is 17, and there is a remainder. 17 divided by 2 is 8, with 1 left over. Divided by 2 is 4, no carry over there, is 2, no carry over there, and 2 divided by 2 is 1, and then we have 1 left over, so we just chuck him in there. Okay, so the way that I remembered this is, I think of it as a tree. Alright, so someone's chopped the tree down, the numbers at the top of the tree will fall out at the furthest reach. So we have 0, 1, 0, 1, 0, 1, 1, 0, 0, 0, and 1. And it's as simple as that. And if I okay, just do a quick check, make sure that that's right. Zero, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1. Excellent, it worked. So now you know how to convert to and from binary. Cool.